A curve C has parametric equations. X is equal to t squared plus 2t and y is 1 over t, where t is the parameter and t is greater than or equal to 0. Find the exact area of the region R bounded by C and the lines x is equal to 3 and x is equal to 8, and then find the exact volume of the solid formed when R is rotated through 2 pi radians about the x-axis. If we will have a look at this, okay, so we've got this is going to be a 3D graph. We can look at the for the volume of revolution later. If we look at this graph here, and if I do the top slider, and this applet I will put in the notes of the video, and move it along like this, the curve will appear like that. Okay, so I've now got the curve drawn from 0 to from t is equal to 0 to 5. So what you put a value of t in, and it generates values of x and y coordinates which follow a curve. So we wanted the area between a is equal to 3 and b is equal to 8. So we've got the answer here. So what we want to do is find this area here, but using these two curves to find the integration. So there's a diagram what I've just shown you. So we're trying to find this area here. So the area will be the integral from 3 to 8 of y dx. So a will be equal to y dx. Now we haven't got the curve in terms of y, we've got the curve in terms of x and y in terms of t. So we can have y, and then we can do dx dt using the chain rule here, and therefore we don't have to find an explicit curve in terms of y is equal to. So if we do that, we have to change the limits, because these are limits of x and x, and we need limits of t. So changing the limits, so when x is equal to 3, and using this one here, we're going to put that t squared plus 2t is equal to 3, t squared plus 2t minus 3 is equal to 0. That's going to give me t, factorising t minus 1, t plus 3 is equal to 0, which gives t is equal to 1, or t is equal to minus 3, but we can ignore this one because we have to consider t greater than or equal to 0. Similarly, when t is equal to 8, we get that t squared plus 2t is equal to 8. T squared plus 2t minus 8 is equal to 0. We factorise that, t minus 2, t plus 4. And then we get that t is equal to 2, and then we're going to get 1 here, which we're going to not use. T is equal to minus 4, which is not possible as t is greater than or equal to 0. So we've got x is equal to t squared plus 2t, so we will need to find dx dt, so that's 2t plus 2. So the area from 3 to 8 of y dx will be the area from 1 to 2. These are parameters of t now. Y dx dt dt. So that's going to be y, which is 1 over t, times the differential of x, which is 2t plus 2 dt. Simplifying that, we're going to have 2 plus 2 over t when we multiply that through. And then if we integrate, we're going to get 2t, and this is going to be 2 ln of t from 1 to 2. Putting in the limits, we're going to get 2 times 2 plus 2 ln of 2 minus 2 times 1 minus 2 ln of 1. Well, ln of 1 is 0, and therefore we're going to have 4 take away 2, which gives me 2 plus 2 ln of 2, and that is the same as 3.39 approximately. Okay, for the second part, we need to find the volume of revolution. So the volume of revolution is pi from 3 to 8 of y squared dx, which is pi from 1 to 2 of y squared. Remember, we can write dx dt dt. So there's going to be pi. We don't have to change the limits because we've already done that in the first part. From 1 to t of 1 over t squared times 2t plus 2 dt. So that's going to be from pi from 1 to 2 of 2 over t, if we multiply 1 over t squared into this, and then 2 over t squared. So it's going to be pi from 1 to 2, 2 over t squared. This is 2t to the minus 2 dt. The first part of the integral is going to be pi times 2 times ln of t, and this is going to be from 2t to the minus 1 with a minus sign in front, because if you do minus 1 times minus 1, you're going to get plus 2, and then reduce the power by 1, you get minus 2 from 2 to 1. Putting in the limits, you get 2 times ln of 2 minus 2 over 2, because it's 2 over t, minus 2 ln of 1, and then minus is going to give me plus 2 over 1. So it's going to give me pi times 2 times ln of 2, and then we're going to get minus 1 from here, and then plus 2 from here will give me plus 1. Now, if we go back to our applet, okay, and if I press the start button, like I've said, the notes in the notes of the video, I'll put the link for this GeoGebra. So here we have the same area here as here. What we're going to do, we're going to rotate that round the x-axis. So if I press start, and you can see it starting there. If I move it around an angle, you might be able to see a bit better. And you can see what's happening, the curves going around the x-axis to pi radians. And then we get our 3D shape. Okay, if you press reset, that will take the thing back to 0, and then if you click in here and then take the second one, that will remove it. Okay, and then if you click here, and I think it's this one here, no, sorry, this one at the end, and then put on your 3D glasses, you'll be able to see this in 3D. So if we go now start, okay, we can now be able to see this in 3D, but you do have to have red cyan glasses in order to see this, but you'll be able to see it in 3D. But don't worry if you can't, just so you can get the actual 3D effect, what it is. Okay, so here we've had the same curve, and we've had rotated a bit between 3 and 8 around the x-axis. So there's a diagram of what we've just done. Okay, I hope you've understood, and I thank you very much for watching, and I'll just repeat that the GeoGebra applet that goes with this video will be in the notes of the video. I thank you very much for watching.